All right, this is Ms. Schneider. You guys are on target 1, and hopefully you've done that little table activity and start to see some parallels and connections between sort of simplified versions of algebraic expressions and maybe some weird things in your table about what x can't be, what makes it undefined, gave you an error in your calculator, things like that. So we're going to start to formalize those connections inside some Cornell notes. And so what I want you to do is take out your notebook and flip to the section where you're taking your Cornell notes, and we're going to do this objective, which is I can simplify an algebraic fraction and restrict the domain. We're going to talk about kind of what we know already, what x can't be. We're going to do some examples all together, write some steps out, and then you'll have some to try on your own. Okay? Here's what we know already. So we know that 1 divided by 1 is 1. Okay? You're going to start to see some patterns emerge. The next thing I'm going to ask you is then 12 divided by 12. And again, that also equals 1, okay? I could ask you something with negative numbers. So I could say, what is negative 34 divided by negative 34? Okay, and again, that is 1. And this idea of dividing and making ones is going to kind of be what helps us simplify our fractions as we go. So I could ask you then, what is x divided by x? And any number divided by itself, you might be screaming at me through the computer that this is just 1. Okay, any number divided by itself is 1. So as we're simplifying these algebraic fractions, you're going to look for things that are the same on the top and the bottom of the fraction, because anything divided by itself equals 1, and then we can just kind of get rid of that. Okay, so you might start to see examples that are a little more complicated, maybe something like x plus 5 over x plus 5. And that in itself also equals 1, right? If I plugged in 2 for x, I would have 7 over 7, which is 1. Any number I plug in for x there is going to give me a fraction that equals 1. Okay? I could make it even more complicated. I could say, what is x squared minus 2x plus 1 over x squared minus 2x plus 1? And that also is 1. Whatever I plug in for x, I'm going to have the same thing on the top and the bottom, and we know from above that those all equal 1. Okay, you're starting to see a theme here, but you have to be careful because not everything I'm able to just kind of cross out on the top and the bottom and make that equal 1. For example, here, a common mistake that students want to make is they want to say that x squared over x squared is 1, and 2x over 2x is 1, and say that this equals negative 7 over 4. But you can't do that. Okay, the only time this works is when things are separated by multiplication, not separated by addition and subtraction. So that's a big no-no, you can't do that. And what we're going to see is that we have to use a lot of factoring to get things separated by multiplication instead. Okay, and you'll kind of see that come up. But please, please, please don't make that mistake where you cross out the x squareds and the 2x's like that. If they are touching a plus and a minus on the sides, then you can't cross those out. Okay? Now, when I'm dividing numbers, I have to be careful because I can't always divide. Think about dividing as I'm putting however many things on the top into however many groups are on the bottom of my fraction. So I can do something like 0 divided by 1, that equals 0. I can put no things into one group, and each of my groups has no things. But I cannot do 2 divided by 0, and those of you who know me know that I have a shirt that says it's all fun and games until somebody divides by 0. So we can't divide by 0. We can't have 0 on the numerator because I can't put 2 things into no groups. It's not possible. So things are undefined when there's 0 in the denominator. So you're going to see in our fractions, if I have something like x minus 3 over x minus 3, that x minus 3 in the denominator can't equal 0. Okay, so we'll write it like this. We'll say, okay, this denominator, x minus 3, is not equal to 0. And we have to figure out what can't x be. Whatever x makes that denominator equal 0, it can't be. So if x minus 3 can't equal 0, I have to figure out, okay, what does that mean about x then? What can't that be? So if I just add 3 to both sides there, I would say that x cannot equal 3. So what I can do is I can divide here to make ones, and this x divided by 3, or x minus 3 divided by x minus 3, that equals 1, like I have written here, but with the restriction that x cannot equal 3. Okay? Let's see that again. I could do something like 2x minus 1 over 2x minus 1, and we know that that equals 1 because the whole 2x minus 1 cancels out and divides to make 1 with that whole 2x minus 1 on the bottom. But that restricted then says that 2x minus 1 can equal 0, is not equal to 0. So that's an important piece. You have to write that as you're solving this problem. So what I would do here is I would add 1, and I would say, okay, 2x can equal 1. And then I would divide by 2 on both sides here. Down here at the bottom, I would divide both sides by 2, and I would say, okay, x cannot equal 1/2. So this whole fraction equals 1, but x can't equal 1/2. Okay, that's my restriction. Let's try that one more time. Actually, let's try that 4 more times, but let's do some bigger, more difficult problems. Okay, so you're going to see here on the top, the first thing I'm going to do when I see a problem is I'm going to factor it if I need to. Now, in this first example, my problem is already factored here. I already have the 2 sets of parentheses on top and the 2 sets of parentheses on the bottom. So that's already factored. But what I want to do is I want to see how the domain is restricted second. That's my second step. So the first thing I know is that m plus 6 can't equal 0, okay? And so I set that equal, well, not equal to 0, and then I subtract 6. So that means that m can't equal 6, or negative 6. If m equals negative 6, then this parenthesis is 0, and 0 times whatever that is would be 0, and then I'd be dividing by 0, and that would be bad. The other thing I know is that 3m plus 1 cannot equal 0. Okay, so here I would subtract 1, and I would get, and then I would divide by 3, and I would say that m cannot equal negative 1/3. Okay, those are the 2 pieces of my domain that are restricted. Now make sure that you're not writing m equals, you're writing m cannot equal with that little slash through it. That's important. Okay, now I can't do crazy things like cross off the m with the 2 here, with the m with the 3 here, but what I can do is, if you notice, this m plus 6 is touching by multiplication on both sides, and so is this m plus 6. So I can cancel those 2. I can divide those 2 to make 1, and then all I'm left with here is 2m minus 5 over 3m plus 1. So I'm simplifying this problem, and this is my answer with the restriction that m cannot equal negative 6 and m cannot equal negative 1/3. Okay, let's try again. Now here, this is factored as well. There's only one thing that one factor that I have to pay attention to on the bottom. N minus 2 cannot equal 0, which means that n cannot equal 2. I would add that 2 over to both sides. Okay, now the top of this fraction says 6 times n minus 2 squared, which is really just 6 times n minus 2 twice. It's going to look something like this. And then the bottom is 3 times n minus 2. I can divide n minus 2 divided by n minus 2, and that equals 1, and that goes away. And then I'm left with just 6 times n minus 2 on top, and just a 3 on the bottom. I can't cross out anything crazy from here, except that here this 6 is only touching multiplication, and this 3 is all by itself. So I can simplify 6 over 3, and 6 divided by 3 is just 2. Okay, so I can simplify, and this right here is my final answer with the restriction that n cannot equal 2. Okay, now on this example down here, go ahead and copy that down. I have some crazy things happening here. You cannot cross off those x squareds, and you cannot cross off those 9s. Those are touching pluses and minuses, and you can't do it. Okay, so what you can do is you can factor with the box and diamond, or in your head, both the top and the bottom, to try and make things that will divide away to 1. Okay, so what I'm going to do is this. I'm going to box and diamond the top, and if you know how to do this in your head, if you learned that from your teacher, feel free to go ahead and do that in your head without the box and diamond, because it's just a 1x squared in the front. But I'm going to quick draw my box and diamond, which gives me a 9x squared on the top and a 6x on the bottom of my diamond. And the 2 things that multiply to 9x squared and add to 6x are 3x and 3x. So I'm going to put those in my box. And then it goes ahead and factors to x plus 3 and x plus 3. Okay? If you notice on the bottom here, I have to factor this as well, but this is a difference of squares. And so x squared is a perfect squared, and so is negative 9. And so I can go ahead and separate those. I put an x first, a 3 as my second in both terms, and then 1 plus and 1 minus. Okay, now that it's factored, you might want to jump the gun and try and start dividing to make 1 here and canceling things out. But instead, I'm going to work on restricting the domain first. So if I look at the bottom, I know that x plus 3 cannot equal 0. That comes from this first parenthesis, and that means that x cannot equal negative 3. And then from the second parenthesis, I see that x minus 3 cannot equal 0, which means that x also can't be positive 3. Okay, I'm going to go ahead and divide those x plus 3's to get a 1, and then all I'm left with is x plus 3 over x minus 3. Don't cross anything else out, as tempting as it is. You cannot do it, so just leave it there. Okay? Now, the factoring on this last one's a little weird. This is a greatest common factor factoring. And so what I'm going to be doing here is just on the top, I can't do a box and diamond, but I can take an x out to the front. And when I take an x out to the front, that greatest common factor, I'm just left with x plus 4 inside the parentheses. I can do the same thing on the bottom. I'm just looking for that greatest common factor, which is 2. I take that out to the front, and I just have x plus 4 left in the parentheses. Okay, time to restrict my domain. The denominator can't have a 0, so x plus 4 cannot equal 0, which means that x cannot equal negative 4. And then those x plus 4's go away because they divide to make 1. And then I'm just left with x divided by 2. Okay, it's kind of a lot. It's a long process. Let's put down the steps there, okay? So I accidentally wrote these in the wrong order, but your first step is going to be to factor if you need to, factor if need be. The second step is to tell me what x can't be and go ahead and restrict that domain. That's what we call that, what x cannot be. And then the third step is to go ahead and simplify by making ones, dividing away to make ones, okay? Now, go ahead and pause if you need to in order to get those steps written down. I'm going to move on though. And now I want you to try some examples. So you are going to do two things. You're going to copy these down. You're going to tell me what can't x be. And then you are going to simplify them by factoring if you need to, and then dividing to make ones and make that a simpler fraction. Okay, pause it, take a couple minutes, get that factored out, and then let's see if you got the right answers. Go ahead and press play again when you're ready. Alright, now this first one, the one thing I want you to notice is that 4x minus 1 was the only thing left here, but that was in the denominator, so it has to stay in the denominator in your answer. X could not be 1/4 or 0.25. If you had that is fine, and x also can't be 3/2 or 1.5. Here, I had to box and diamond both the top and the bottom because they don't have an x squared in the front. There's a number, so I had to do the actual box and diamond. But I ended up with 2x minus 5 over 3x plus 1, and x could not equal negative 1/3, which is the same thing as negative 0.33 or negative 2. Those are the two things that x could not be. Okay, go ahead and move on to that Google form practice, and once you get 80% on that, you can take your mastery check.